10, 9, 8, 7, 6, start, 2, 1, boost ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond. Well,
the biggest cost factor in building rockets isn't actually the fuel or oxidizer, it is in fact the metal component, the rocket itself. One solution to reducing the price of putting stuff into space is to create recoverable rockets. Currently, SpaceX has created a recoverable rocket in their Falcon rocket, but so did NASA with the Space Shuttle. Because they get banged up in re-entry and burnt, the main issue is that it costs more to actually refurbish them than it does to build a new rocket from scratch, because refurbishment also requires you to bring up the rocket to acceptable safety standards. One thought in how to get rockets a little cheaper into space is to, on the launch pad, create a large pogo stick-like spring that you would attach the rocket to. Give it a little more boost in order to save just a little bit on fuel, and when you're launching a rocket, every little bit cheapens it by tens of thousands of dollars. Another thought on how to get rockets into space more easily would be to shoot a laser at the rocket from the ground. Now, the laser would actually provide the energy required for ignition without needing that energy to be supplied on the rocket, saving lots of money. An additional thought is to put a laser on the rocket itself to shoot forward, making the air hotter in front of it. This would make the air less dense, and in a way it would steer the rocket as it would tend to go towards the less dense air, thus making it go straighter, as well as providing less air resistance. But one issue with the laser proposal is that our current US laser technology can only use 1 megawatt laser firing for about 1 minute straight. The laser proposed to help get a rocket into space would have to be 500 megawatts and would also have to fire for 10 straight minutes. Now imagine this. A country gets a 500 megawatt laser that can fire anywhere in the world with a simple reflective surface and also travels at the speed of light. This laser is powerful enough to vaporize cities, small countries even. It would ruin economies and become the ultimate weapon of war. This is one of the reasons why the mega laser can't actually be used feasibly. Another proposal on how to get cargo into space is with space planes, which are planes that can go so fast that they can actually reach escape velocity. Currently, commercial jet planes use what are called turbofans, or the big turbines strapped to the wings. These suck in air, add fuel, and ignite that fuel to create a large amount of exhaust wind, propelling the airplane forward. These work when you're going a few hundred miles an hour, but once you get past that, they're simply not capable of getting the speed to reach escape velocity. That would require a ramjet, which is an engine that, instead of sucking in air itself, it has to be used when the plane is going so fast that the air is forcing itself into the engine on its own. It then adds fuel and ignites that fuel, creating an even stronger exhaust wind. Ramjets are good and all, but they can't reach escape velocity. They can only reach about Mach 7 or 5,000 miles an hour. You'd have to reach 25,000 miles an hour to escape Earth. That's where scramjets come in. Scramjets are like ramjets, except instead of injecting fuel to ignite to create the exhaust wind, the scramjets ignite the air itself, pocketing the oxygen so densely that even the smallest amount of hydrogen burns explosively. These are capable of actually reaching Mach 21 theoretically, though they're still prototypes and haven't been created past that point.